Problems on operation of DT signal. So the first problem is discrete time signal is given by discrete time signal is given by x of n is equal to 1 1 1 1 2. So sketch the signals. Sketch the following signals. So first signal we have to sketch is x of n minus 2. So before that we will write the given sequence once again. So given sequence is x of n is equal to 1 1 1 1 2. So here we know that arrow indicate the position of the sample at n is equal to 0. So this arrow indicates the position of the sample at n is equal to 0. Thus the value of xn for different values of n are, so x of minus 1 is 1, x of 0 is 1, this is x of 0, this is x of 1 is 1, x of 2 is 1, and this is x of 3, it is 2. So for that first we draw the sequence. So this is n, it is x of n which is 1 1 1 1 2. So this is 0 1 2 3 and it is minus 1. For minus 1 value is 1. For 0 also it is 1. This is also 1. And for 3 it is 2. So this is given sequence. This figure shows given sequence x of n. So first we have to draw the signal x of n minus 2. Now here negative sign indicates that a delay operation. Negative sign means delay operation. So delay operation means shift the diagram towards the right. So we have to shift the sequence this xn towards right by 2 samples. Here negative sign is given in the problem, so it is delay operation. And for delay operation we have to shift the diagram towards right. So we shift this given sequence xn towards right by 2 samples. So the diagram is, so for this the diagram is this is n, it is x of n minus 2. This is 0 1 2 3 4 and 5. So we shift this towards right by 2. So it is 2 1 1 1 1. Originally the arrow was here, now the arrow is at this place, so it is, now it is 0. So for 0 it is 0. For next, for x of 1 it is 1 1. This is x of 0, x of 1, x of 2, x of 3, x of 4, and this is x of 5. For x of 5 the value is 2. So this is the sequence for x of n minus 2. Now the next sequence we have to draw is second problem. It is x of n plus 1. Now here positive sign is given. So positive sign indicates that the signal there is a advance operation. For negative it is delay and for positive it is advance operation. and advance operation means we have to shift the diagram towards the left. So we will shift the sequence xn towards left by, as it is plus 1, by one sample. So the diagram becomes, this is n, it is 0, 1, 2, this is minus 1, minus 2, this is x of n plus 1. Now we will shift this towards this direction. So it is 1, 1, 1, 1, 2 by one sample. So originally the arrow was here, now it will be at this point. So this is for x of 0, it is 1. For x of minus 0, it is 1. For x of minus 2 also it is 1. For x of 1 it is 1. And for this it is 2. So this is the sequence for x of n plus 1. Now next is x of 3 minus n. So x of 3 minus n means here the sequence can be written as x of minus n plus 3. So minus n means folding operation. So we write here sequence can be x of minus n plus 3, and this minus n is folding operation. This minus n is folding operation. So in the case of folded, the positive sign means delay operation. So we write here, in case of folded signal, positive sign means delay operation. Positive sign means delay operation, and delay means shift the diagram towards right. Delay means shift towards right. So the folds, first we have to fold the sequence, that is first we have to obtain the x of n to x of minus n and then shift the diagram. So first fold the sequence x of n to x of minus n and then shift this diagram towards right by 3 samples. So first we have to draw x of minus n. This is x of minus n is 2, 1, 1, 1, 1. Zero, 1, minus 1, minus 2, minus 3. For this is x of 0, x of 1, x of minus 1, minus 2 and minus 3. So for minus 3 value is 2. For this is 1. This sequence is x of minus n. Now we have to draw for x of minus n plus 3 for delay operation. Now we have to apply delay operation. So this is n, it is x of minus n plus 3. So signal becomes 2, 1, 1, 1, 1. Delay means shift towards right by 3. So originally the arrow is here, now it is shifted towards 2. So this is x of 0, 0, 1, 2, 3 and 4. So for x of 0 it is 2, for all other values it is 1. So this diagram is x of 3 minus, this sequence is x of 3 minus n, or we can write minus n plus 3. Next is x of n into u of n minus 1. So this operation indicates the multiplication of xn into u of n minus 1. So first we draw u of n. U of n use the unity signal, so it is and u of n and 0, 1, 2, 3. So it is 1, 1, 1, 1. So this is signal u of n. Now we have to apply the delay signal. So it is u of n minus 1. So if u of n minus 1 means we have to shift the signal by one sample. This is 0, 1, 2, 3 and 4. This is n. We have to shift this signal by one sample. So it is 1, 1, 1. This is u of n minus 1. Now we get u of n minus 1. Now what is xn? Xn is given. Yes, xn is xn. It is minus 1, 0, 1, 2, 3 and this is 4. Okay, so for 3 it is 2 and for all other values it is 1. So this is x of n signal. And now next is multiplication of xn and u of n minus 1. So this is multiplication of both these and we get the answer as multiplication of both these signal. So we get xn into u of n minus 1. We get so for 0 it is 0 into 1. So we get here for 0 it is 0. For minus 1 it is 0 into minus 1. So for minus 1 also 0. For 1 it is 1 into 1 is 1. 2, 3 and 4. For 2 it is 1 into 1. For 3 it is 2 into 1. So it is 2. And for 4 it is 1 into 0. So this signal is x of n and into u of n minus 1. So what is un signal? Un signal means un means unit step and u of n minus 1 means the unit step is delayed by one sample. So first we draw un signal, that is unit step signal, then we draw u of n minus 1 signal, and then take the multiplication of u of n minus 1 and xn, and finally the final diagram is this, that is x of n into u of n minus 1. Now the next is fifth one in this. Now the next is x of n minus 1 into delta of n minus 1. Now this operation indicates the multiplication of x of n minus 1 and delta of n minus 1. So first we have to draw x of n minus 1. So we have xn. So first we draw the xn signal. So this is xn signal. It is n. It is xn. It is 0, minus 1, 1, 2, 3. This is 1. This is 1. One, and it is 2. Now this is original xn signal. Next we have to apply the delaying operation. So we get x of n minus 1 signal. So we have to shift the diagram towards right by one sample. So it is n. This is 0, 1, 2, 3 and 4. So for here it is 1. We have to shift this diagram as it is towards right by one sample, and here we get it is 2. So this is x of n minus 1 signal. Next we have to draw delta of n minus 1. For that we have to draw the original delta L signal. So this is n and it is delta of n. Delta of n means 1. It has value 1 only at 0. That is, here the value is 1, and for all other values it is 0. At 0 it is 1, and at other, that is at 1, 2, 3, the value is 0. So we have to apply the delaying operation to this also. So it is delta of n minus 1. So we have to shift this original signal delta n by one sample towards left. So it is, here it is 1, and at rest of the it is 0, 1, 2, 3, 4, it is 0, 0, 0. Now we get xn, x of n minus 1 and delta of n minus 1. Now we have to apply the multiplication of these two, on these two signals, and we get the final result. So it is x of n minus 1 into delta of n minus 1. So it is 0, 1, 2, 3, 4. So it is 0, 0 into 1 is 0, 1 it is 1 into 1, and at all other values it is 0, 0, 0. So we can denote this signal as 0, 1, 0, 0, 0. At 0, x of 0 it is 0. So this is x of n minus 1 into delta of n minus 1. So here also first we apply the delay signal to the x of n signal, then we apply delay. Delta n is actually unit impulse, so we apply the delay signal to the unit impulse, and then we take the multiplication of x of n minus 1 into delta of n minus 1, and we get the final result. Now the next problem is different, that is find odd and even components. Now find odd and even components of the signal. So x of n is equal to u of n minus u of n minus 4. So we have to find the odd and even components of this given signal, and this type of problems was asked in exam for 4 marks. So first we draw what is given, xn is equal to un minus u of n minus 4. So first we draw the signal un. Un means unity signal, so we have value 1 everywhere, it is u of n. Okay, next is we have to draw u of n minus 4. So u of n minus 4 means we have to shift this signal by 4 samples. So it is 1, it is 0, 1, 2, 3, it is 4 and 5. It is u of n minus 4. So we have to shift this by 4 samples. So 0, 1, 2, 3. These are the 4 samples. Now it is, here it is 1 and 1 dot dot. And then we have to subtract these two signals, u of n minus u of n minus 4, and we get the output signal as we have to take the subtraction of these two signals. It is 0, 1, 2, 3. So we get here 1, 1, 1, 1. It is the signals u of n minus u of n minus 4. So here it is 1, 1, 1, 1. Therefore, what we obtain, xn signal is obtained, this is, and its value is 1, 1, 1, 1. At x equal to 0, 1, 2 and 3, it is 1, 1, 1, 1. And x of minus n is, it is folded signal, so it is 1, 1, 1, 1, but the arrow is here. Now we have to find the even component. So for even component, x e of n is equal to 1 by 2 into x of n plus x of minus n. So it is 1 by 2. Here we directly add these two signal and divide by 2, and the answer is, it is 0.5, 0.5, 0.5, 1, 0.5, 0.5, 5. So this is even signal and odd component. And our odd component is xo of n is equal to 1 by 2 into x of n minus x of minus n. So here we directly write the answer minus 0.5 minus 0.5 minus 5. Sorry, it is 0.5, 0.5, 0.5. So these are the odd and even components of the signal. Next is the problem on operations of CT signal. Next is solve problems on operation of CT signal. So the first problem is, this type of problem was for the 4 marks, was asked in university exam for 4 marks. Perform the following operations on given signal. Right here, perform the following operation on given signal xt, which is x of t is equal to minus t and 0. For minus t it is in between 0 and minus 4, t it is 0 and t 2, and otherwise it is 0. So first is sketch signal. Sketch the signal x of t, and second is sketch the signal z of t is equal to x of minus t minus 1. So this signal is given x of t equal to minus t, t and 0. So your notation t means it is a ramp signal r of t. So here t means a ramp signal r of t and minus t is folded ramp. So the ramp signal t is from 0 to 2 and folded signal minus t is from minus 4 to 0. So first we'll draw this signal. So you can write here notation t means it is a ramp signal r of t and minus t is folded ramp. So ramp signal t is from 0 to 2 and folded ramp minus t is from minus 4 to 0. So we draw this signal. First we draw x of t. This is x of t. So x of t is 0, 1, 2, minus 1, minus 2, minus 3 and minus 4. So from minus 4 to 0 the value is minus t. It is 1, 2, 3, 4. It is a ramp signal. So this is x of t and now we have to draw x of minus t. So x of minus t is folded signal. So it is 0, 1, 2, 3 and 4 and it is minus 1, minus 2. It is 1, 2, 3 and 4. So this signal is x of minus t. So by using the time shifting property, z of t is obtained by shifting x of minus t by 1. So we have to draw the x of z of t. So what is z of t? Z of t is equal to x of minus t minus 1. We already obtained x of minus t. We just apply x of minus t minus 1. So we get this is t, this is z of t is equal to x of minus t minus 1. So we have to shift the signal towards, it is 3, 4 and 5 and it is minus 1, towards right by one sample. So it is 1, 2, 3 and 4. So this signal is z of t, that is x of minus t minus 1. This type of problem was for 4 marks, was asked in exam.